Alright guys, so in this video, we're gonna quickly talk about simple harmonic motion, okay? So what is simple harmonic motion, and then what are some quantities that we need to know about simple harmonic motion, okay? So basically you've learned last year, it's like we have like projectile motion, right? And we have circular motion, and these are the different types of motions, like constant speed, constant acceleration, that's where we started. And once we get into more complicated motion, then we need to have different methods to deal with them, right? So so simple harmonic motion. So first we got to know what is it? What is this simple harmonic motion? So it's kind of, so here we define, say, simple harmonic motion is a type of oscillatory motion. Okay, oscillatory means it's like going up and down or left and right. So it's going like this, and then where the restoring force is directly proportional to the displacement and acts in the opposite direction. So we have an equation, definition here. The definition is the acceleration need to be proportional to the displacement. Displacement we use y. So and it's acting in the negative direction. Okay. So if the acceleration is in the negative direction of displacement and proportional, that means there need to be a restoring force, because force causes acceleration, right? So you can either say there's a restoring force, or you can say there's a restoring acceleration, okay? Because force causes acceleration, okay? And then there is the equation over here, which is how much is this proportion? So proportion, we can say y equal to kx, right? Y is proportional to x, and then maybe it's acting in the negative direction, but there is a ratio over here, and that ratio is the value. So what is that value? That value is gonna be omega squared y, okay? And then we're gonna find out, well, what is omega? Omega angular speed. So why do we have angular speed? And why is that? So this equation, I write it over here because that is the equation that's given to you in your exam. And later you can use this equation to calculate either acceleration or y, okay? But for now, we just need to know there is this equation. But for now, all we need to know is this one over here, okay? All right, so, and then the next part, we are gonna look at some of the definitions over here. All right, so typically we have two types of thing we're gonna deal with. One is gonna be a horizontal vibration, and then the other one is a vertical, okay? So the typical vertical one is we put a mass on a spring. So if you have a spring and then you put a mass on it and then you pull it down, and then boom, 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 started bouncing up and down, okay? Or you have a pendulum, it's going left and right, left and right, left and right. And then the other example we had was the one we've just done, the experiment where we have a compound spring, two springs, and then have a cart and then bouncing left to right, okay? So let's have a think, why does it matches us? Say we use a compound spring over here, right? So that is a little cart, another spring over here. Say right now, this middle position, we give it a name, we call it equilibrium. That is the equilibrium position, okay? And then once you pull it to the side, it will start to have a displacement. Say this is gonna be the displacement y, okay? And once you pull it to the right, what is the direction of acceleration? So acceleration will be going to the left. So this object is going to have an acceleration going to the left. And you can see the direction of these two are opposite, right? And the bigger the y, the bigger the acceleration is going to be. So it's going to be proportional, right? Proportional. But it's acting in the negative direction. So the more you pull on the outside, the more it's going to go accelerating, wanting to accelerate in that direction, okay? All right, and then over here we say speed is 0 at end position. So if we're vibrating like that, speed is going to be 0 when it's reaching this end, and it's reaching 0 when the displacement is maximum, okay? Y is the displacement. And then acceleration will be the maximum over here. Okay, and then when it's reaching to the middle, that's when the speed is going to be biggest. But in the middle, there's no acceleration, because the spring, the two forces pulling them are going to be equal size, so they cancel out each other, okay? Yeah. So that's acceleration and speed and how that differs. So we define what is displacement and what is amplitude. Displacement is how far away it is from the equilibrium position. Okay, if I say this is a positive value, say positive 0.3 say meter, and then when it comes to this side, it will become a negative 0.3 meter. Okay, and in the middle is a 0. We use positive and negative to show the direction. Which side are you going to be on? And you can define. If you say this is positive side, then that will be the negative side. Okay. All right. And then the next one is we have a period or amplitude. So amplitude is the maximum displacement. Say I pulled it over here. Amplitude equal to 0.5 meter. Okay. And then I released it and then started moving. So the amplitude is the total, the maximum displacement that you normally start with, okay? And then once you go there, then it might become smaller if there's some energy loss. But displacement is at a particular moment where the object is from the original position, okay? All right, so next one, period. Period is time taken for one oscillation, so you know that. Frequency is in 1 second how many oscillations you can have. So that's all pretty straightforward, okay? T equals to 1 over F. That is the equation we've learned before. Okay, so this lesson is pretty straightforward. So in your book, there are a few questions, properties of simple harmonic motion. You guys can have a try. And in your textbook, and then there are these questions you can try as well. So make sure that you can do all of these guys, okay? And obviously, we talk about pendulum and we talk about bouncing mass, okay? So then you just need to analyze those situations. So the next lesson is a difficult one, which is the reference circles. I want to spend a bit more time talking about that one, and I might even look at a few questions with you guys together in that one, okay? All right, have a good day and stay safe.